Good afternoon, everybody. I am Bimal Bhattacharya from Space Application Center, ISRO, Ahmedabad. I am very delighted to deliver this talk on joint Indo-French TIR-VSWIR science mission, TRISHNA, towards global water and food security. And my co-authors are science members of CNES team from CNES and SESBio and FDMARD. So we have jointly prepared this presentation to deliver this talk. So if we see that recent trend of global warming, which is actually showing the temperature anomaly which has taken place up to 2020, which is of the order of zero point 0.5 to 1 degree centigrade of 5-year mean anomaly. And if we further see the future trend in the global surface temperature, that is also showing there is a chance of increasing up to 1.5 degrees centigrade, maybe around 2050 and also beyond that. And what are the causes? All module simulations in CMIP 6 simulations showed that it is due to CO2 and CH4 increase. But why it is so? It is shown in the IPCC summary report 2021 that human-induced global warming actually plays prominent role than the natural forcing factors. So why such strong human-induced changes? If we see the current and future population growth, it is increasing almost linearly, but after 2050 there is a trend that the rate of increase may take a plateau or it may decrease. However, if we see among the increasing population, these 95% of world populations is living on land, and that includes 40% who are living in the coast. Now, because of human population growth, there is increasing demand and consumption of different resources such as food, water, forest products, energy, and minerals. And there are causes of large scale land use changes, and it happens in the form of change in cropping pattern, then irrigation, deforestation, then desertification, land degradation, and different other urbanization and industrialization. So all these lead to actually global warming, and also there is alteration in the energy, water, and the biogeochemical cycle process. So this causes the changes in long-term weather pattern, and finally we are seeing the increasing the different extreme events, and these have a lot of impacts on ecosystem in terms of food, water, and nutrient security, extinction and declination of different species, and the phenology and range shifts, as well as the newer adaptation and evolution, and it has impact on health and natural disturbances. So there are different signals of global warming, which is starting from the ecosystem stress, then it causes drought, then urban heat island, then we are seeing the increasing flood conditions, sea rise, then shrinking ice sheets, and the retreat of glaciers. If we see the most human-induced change, so there we can see the water is mostly threatened. So 70% of world water actually is being used by agriculture, and rest is being used for the domestic purpose and industry. And if we see the water withdrawal from agriculture, it is very high over Asian region, African region, and many different other parts of the world. and 20% irrigated land actually produces 45% food production. And all these actually lead to, say especially for India, 54% actually faces high to extremely high water stress condition. So, based on per capita water availability, India is moving from water stress that is less than 1700 meter cube to water scarce nation, 1000 meter cube. So, this is a very grim situation. And if we see the water and food security nexus, currently actually 7 billion people are being fed, but in 2050, 9 billion people actually needs the 60% more food to be produced, and it triggers the 19% increase of agricultural water consumption. If we see a person who drinks 2 to 4 liters of water per day, however, indirectly he consumes 2000 to 5000 liters of water through different food items. Suppose for growing one apple, 70 liters of water is required, and suppose for producing a bread, 40 liters of water is required. So if we see that these are actually form the basis of the virtual water consumption, and this virtual water consumption actually plays bigger role the actual drinking water. And water use on the right side, if we see the FAO manual, where it says the water use actually grew at almost twice the rate of population increase, and the irrigation food production will increase by more than 50% during 2050. However, the water withdrawn for agriculture will increase only 10%. So how it can be possible? It can be only possible through efficient water use to increase the crop water productivity, and for that actually better data acquisition and mapping are required so that it can drive the water rights and the optimized allocation, and the incentives for control measures, expansion of efficient micro irrigation, and also it can trigger the policymakers to reduce high subsidies for water, energy, and the fertilizer use. So, if we see the agricultural water consumption and water productivity over Indian perspective, we have seen that from the 30 years of data analysis of the thermal infrared, though at the Scorsese resolution from NOAA, VHR, and MODIS, we could estimate the irrigated water consumptive use and the rainfed water consumptive use over India. It shows that irrigated water use actually increases 4 cubic kilometer per year, and there is a large gap which exists of 160 kilometer cube between irrigation water withdrawal and the water consumption by agriculture. And two terms are when we go deeper into that we can see that physical water productivity, which is output in terms of yield divided by water consumption, it is actually 4 times less than different agriculturally rich countries, and that drives that economic water productivity or the footprint. In case of India, it is $3 per meter cube, as compared to higher US dollar like 8 to 65 US dollar per meter cube of water use in other countries like Australia, Indonesia, China, and USA. So now how we can manage the water resources through thermal infrared and the visible sphere remote sensing. So one of the important variable in the water budget or the water balance is the evapotranspiration. That actually comes after rainfall, and this evapotranspiration is very sensitive to changes in the surface temperatures, whether it is global scale or regional scale or the plot scale. And finally, the evapotranspiration drives the water demand and how much water use is there, and that can trigger the optimized management of water. So the surface temperature and its dynamics for triggers the surface energy balance, and the surface energy balance actually helps in estimating the latent heat fluxes, and which can be converted into evapotranspiration. And if we see the consumptive water use, which is nothing but the summation of the evapotranspiration from the vegetative systems, there we can see that how these seasonal consumptive water use are different for different crops. And also, if we see the effect of rainfall and the irrigation, there also you can see the how sensitive the latent heat fluxes are, latent heat flux with respect to the rainfall and the irrigation variations. So all these lead to the all these lead to the form the very basis of observing the thermal infrared sensing and for managing the water resources. So there is an observational gap existing if we analyze the current spot, Landsat and different other satellites, which are primarily the in the VNIR and shortwave infrared band regions. And on the other hand, if we see the compare the Aster, Landsat, then Sentinel-3, which actually provide the thermal infrared remote sensing data, but maybe at 1 kilometer, but on the daily Landsat is providing 16 days, but at 100-meter. On the other hand, the optical multispectral data that does not have the thermal infrared. However, for monitoring the water budget at the farm scale, we require at least the daily evapotranspiration, or maybe at the 2 to 3 days interval. Now, if we use only the multispectral data, we can come to know about the crop water requirement through crop coefficient and all this. But how to estimate the stress? So surface temperature provides an energy balance, helps to know the water stress and the actual water consumption, and from that we can come to know that due to rainfall or irrigation, whether the water consumption is sometimes more than the water requirement or less. So these sort of signals actually we can capture from the when we have both thermal infrared and the VSWIR sensing from the same platform. This is one example here where we have seen that from the noon night land surface temperature and the vegetation index and their contextual triangle, the slope of NDVI and this day-night temperature difference, surface temperature difference actually provides a clue to see how the evapotranspiration varies, or evaporative fraction varies throughout the season in response to one year to another year due to the rainfall variability. So in a sense, if we see that in the world, if we want to compute the terrestrial water budget, so there is a GRACE mission which provides the surface water storage chain, then GPM for precipitation, SWOT mission for runoff, but there is no mission for the measuring the evapotranspiration change. So TRISHNA actually will fulfill these gaps, and there will be follow-on missions also in the future which can act as a virtual constellation. Those science objectives of TRISHNA is actually the ecosystem water stress and the water use for better management of water use for food security, and also the coastal and shore and inland waters for water quality, fish resource and sea ice. Though there are different other secondary design drivers like urban microclimate, solid earth, cryosphere, atmosphere, etc. Now, if we see the TRISHNA mission data sets, it is the ISRO CNS cooperation. Launch will be in 2026, and it will have the global coverage. It is having 4 thermal infrared bands, 5 VNIR bands, and 2 SWIR bands. and there will be a revisit period of 3 days, but however 8 days period will be hotspot free observations, and it will have the swath of 1030 kilometer, and overpass time will be the noon time 12:30 p.m. and the 12:30 a.m. in the night. And there is the any delta T of the thermal infrared or land surface temperature will be 0.2 K, and there will be synergies with the SBG, surface biology, geology, thermal infrared payload, as well as LSTM, science and application tips. And there is a free and open data policy for worldwide scientific community. And on the right side, it shows the TRISHNA full cover, so resolution data coverage. And these panel shows the average revisit as programmed for TRISHNA mission. So if we see the bands, as we have seen that VNIR will constitute only the 7 bands, and TIR will have the 4 bands, and there will be different data products like L1 products, and then it will be followed by the different science products which constitute the L2A and L2B. And if we see that there are host of products starting from the atmospheric products, and then surface radiative, biophysical, and the temperature, emissivity, and finally leading to the net available energy and evapotranspiration. So the overall objective is to produce daily evapotranspiration as a level 3 product. And we will be having the joint Calval experiments, which have the directional anisotropy as one of the most prominent scientific activities. And there will be aerial flights, and different models like SCOPE, DART will be used to fine-tune the algorithms, and also to produce the hotspot free land surface temperature and emissivity. So in the primary objectives of the terrestrial ecosystem and water use, main science objective is to monitor the energy and water exchange over continental biosphere, and also to assess water productivity for agriculture to achieve more crop per drop. So we have to rationalize or reduce the consumptive water use. Simultaneously, yield should be increased, and as a result, crop water productivity should be increased. And there are different scientific elements which have been thought of, spread over irrigated agriculture, rain-fed agriculture, and natural vegetation. And if you can see that TRISHNA evapotranspiration, water stress, and biophysical parameters, temperature, acidity will fulfill that to study those scientific elements. And there are multiple societal benefits involved, like watershed vulnerability assessment, management, then advisory to irrigation advisory to farmers, and in terms of cold wave and the disease management, and also the agriculture drought early warning, and improvement in the crop yield forecasting. And in the coastal and inland waters, the science objective spreads over detecting zones of freshwater resources in the fringes, small scale mixing, and the water pollution along thermal gradients for improved coastal water management. So here also these temperature reflectances and different color and indices will help in having different in studying the different scientific elements like algal bloom, haleutic resource, spring discharge, etc. And then it will benefit in terms of the reduction in the search time for the potential fishing zone, as also a reduction in the fuel consumption for the boat owners. So if we see the global linkages, that TRISHNA science product will serve as essential agricultural variables, and GeoGlam actually is planning to has defined several essential agricultural variables, where the land surface temperature and evapotranspiration will form important ingredients to provide that essential agricultural variables for the agriculture science community over the world. And these some TRISHNA products will also serve as the ECVs, and there will be irrigation management guidance by FAO for water and food security, and Global Water Watch. Then the UN Sustainable Development Goals it will cater to through different targets and indicators. And this TRISHNA mission will be followed by two LSTM missions during 2029-30 period, and the surface biology and geology thermal infrared, where these specifications are almost similar to TRISHNA, and the main thing is that time of overpass will be also similar. So that synergy actually you have made. So all these three missions will act as the constellation, virtual constellation of the high resolution thermal infrared and VSWIR mission. So I think it will also provide important data source to the global high resolution surface sea surface temperature community, and especially for the coastal zone and the marine ecosystem resources applications. With that thing, I thank GHR SST forum for providing me the opportunities to deliver this talk. Thank you very much.